Alright, so I feel like I start every video just like that. Alright, so the topic today, this is from section 5, topic 1. And the topic is graphing quadratics in standard form. The essential question or the target is, can you determine and write this part kind of small because there's a lot to it. Can you determine the vertex, comma, axis of symmetry, comma, x-intercepts, comma, y-intercepts, and if the graph opens up or down when given a quadratic equation in standard form. If you can't see, you can move closer.
No, your thing is cutting it off.
You mean like that? Okay. A little picture smaller. Example 1. We have 3x squared plus 2x minus 1. I'm going to put the f of x on the left. You can put it on the right. It doesn't matter, but usually you see it on the left. So you could have f of x there, or y means the same thing, right? So we know we have the graph of a quadratic because our highest degree is 2. We know when you graph a quadratic, this shape is a parabola, which is like a U shape, right? We've talked about that lots of times this year. So I'm going to show you how to graph a parabola not using the graphing calculator, but graphing it by hand, okay? And this has a lot of steps to it, and each one's important, so don't just skip anything, all right? And usually I know we reserve the question section for us to go back and write the questions down later to make a little study guide. But today with a graph on the right side, it's hard to like read your writing, so I'm just going to put all the steps on the question side. And I'm probably even going to use a summary for the questions too because there's a lot of it. All right? So the first thing we're going to do is we're going to determine the opening. And what that means is I'm going to look at the equation and I can tell if the graph of the parabola is going to open up or open down depending on what A is. All right? So if A is greater than 0, then the graph opens upward. If A is less than 0, then the graph opens downward. So we don't even have to do any math to know if our graph's going to open up or down. So in this, when we graph this parabola, will our parabola open up or will it open down? It'll open up, right? Because a is 3, 3 is greater than 0. If a was negative 3, then it would open down. So that part's good to know because say you were taking a test and the graphing part was multiple choice. Well, if you had 2 graphs that opened up and 2 graphs that opened down and you just know this little rule right here, well, that's going to eliminate 2 of the choices right there, right? So that's good to know. It's good information. You don't even have to do any math to be able to determine that. All right, the second thing we're going to do is we're going to determine the axis of symmetry. Remember, parabolas are symmetrical, and the axis of symmetry is like the line that they are mirrored across is the axis of symmetry. And it's a vertical line, and all vertical lines are x equals some number. So to figure out what that number is, you use this little formula, x equals negative b over 2a. And I meant to define what a, b, and c was a little above, but I'll just do that over here on the side. What is my value for a? 3. B equals 2. And c equals negative 1, which I don't need the c for the vertex, but I will later on down the road. So if I want to know the equation of my vertex, I just plug in negative b plus 2a. So x equals negative b, so if b is 2, opposite of that's going to be negative 2 over 2 times a, so that will be 2 times 3. And unfortunately, this is going to have a fraction, but that just happens. We got to deal with it, and we're not even going to turn it into a decimal. So that's negative 2 divided by 6, which reduces to negative 1/3. So my axis of symmetry is going to be at x equals negative 1/3. And I'm going to find all of my parts, and then I'll go back and graph it. Okay? Next thing I'm going to do is I'm going to find the vertex. So to do that, if the axis of symmetry goes through the middle of the vertex, the x value of the axis of symmetry, what x is equal to, is going to be the same as the x value of the vertex, right? So I'm going to say, okay, well, when x is negative 1/3, what is y? So what you do is you substitute what x equals from, I'm going to put a of s. What is a of s? What am I talking about? From the axis of symmetry into the equation we are graphing. So when x is negative 1/3, I want to know what y is equal to. So instead of using f of x, I'm going to use y. Okay, we know they're the same thing. Y equals 3x squared plus 2x minus 1. Wherever I see an x, I'm going to zoom in a little bit here. Wherever I see an x, I will substitute in negative 1/3. Now, a lot of mistakes are made here because of order of operations. Okay, well, parentheses first, well, that means when you have something to simplify inside the parentheses, and we're not turning these into decimals, okay? negative 1/3 squared, do I do that first or do I do 3 times negative 1/3 first? 3 times negative 1/3 first? So multiplication comes before exponents? Please excuse my dear Aunt Sally. Exponents come before multiplication, right? So I have to do negative 1/3 squared first. So we know that's the same thing as negative 1/3 times negative 1/3. And we know that when we multiply two fractions together, we do numerator times numerator. So negative 1 times negative 1 is positive 1. And denominator times denominator. 3 times 3 is 9. So that is 3 times 1/9. And I'm just going to write everything else the way it is for now. Now I've got multiplication, addition, multiplication, subtraction. Order of operations, which part of that do I have to do first? Multiplication. I actually have 2 places to multiply, right? So I'll take care of both of them. When I multiply fractions, numerator times numerator, denominator times denominator. Be careful because a lot of kids go 3 times 1, 3 times 9. That's not right. Remember, 3 is equivalent to 3 over 1 times 1 over 9. So that gives me 3/9, which reduces to 1/3. So 3 times 1/9 is 1/3. And then I have to do 2 times negative 1/3. So I'll do 2 over 1 times negative 1 over 3 gives me negative 2/3. And then just bring down that minus 1. Now I just have subtraction. So work from left to right. Now when I add and subtract fractions, don't I have to have a common denominator? Yeah. Well, my first 2 fractions already have a common denominator. So I just subtract the numerators. What's 1 minus 2? Negative 1, and keep the denominator of 3. Don't forget this minus 1. So do y'all know what negative 1/3 minus 1 is without showing the math? Negative 1 and 1/3, or yes, negative 4/3. I could use that as well. Since this is part of my vertex, it's an ordered pair, I would probably leave it as a mixed number. Okay, so now I know my vertex. My vertex has the same x as what we found in axis of symmetry. So the x is negative 1/3, and we just found that the y value of the vertex is negative 1 and 1/3. Now the next thing we're going to find is the y-intercept. That's the easiest thing to find. The y-intercept, every ordered pair on your y-axis has an x value of 0, correct? Correct, Miss Riley. So one thing you could do is you could take your equation and everywhere you see an x, substitute in a 0, solve for y, okay? But just think about it. If my equation, here's my equation. If I plug in a 0 everywhere I see an x, what's going to happen to my first term? 0. What's going to happen in the middle term? 0. What are we going to be left with? Negative 1. So you can do that every time, or you can just know that your y-intercept is whatever the value of c is, okay? So the y-intercept, sorry I moved this paper up and down so much, is negative 1. Make yourself a note. It's always the value of c. Okay. One more thing we have to find is we found the y-intercept. Now we got to know how to find the x-intercept. And remember, every time I teach you how to solve a quadratic, I say, when you find the solutions, graphically, those solutions tell you where your graph crosses the x-axis, right? So we spent a lot of time figuring out how to solve quadratics. You can solve by factoring, but does factoring always work? No. You can solve by completing the square. Does completing the square always work? Yes. You can solve by using the quadratic formula. Does the quadratic formula always work? Yes. So if you don't even want to play around with factoring, just go straight to the quadratic formula or completing the square. But I always like to factor first because if it works, that's what I want to do, because to me that's the easiest. You may disagree. So to find the x-intercept, you have to solve by either factoring, comma, completing the square, or by using the quadratic formula. So I'm going to try factoring first. So we know, and we have this written above, but I don't want to keep moving my paper up and down, that A was 3, B was 2, and C was equal to -1. Make a little t-chart. On the left side, we want two numbers that multiply together to give us A times C. Well, A times C would be -3. And we want on the right side two numbers that add together to give us B, and B is +2. Any ideas?
B is what?
B is 2.
-3.
Which?
+3, -1.
Yeah.
+3 and -1. Let's see. 3 times -1 is -3. 3 plus -1 is +2. So yep, that works. So remember, we make our two parentheses. The variable is x. And then we look at our t-chart. We need a +3 and a -1. Is it going to be important that we divide and slide on this?
Yes.
Yes, because A is some number other than 1, right? So we're going to divide or we're going to slide by A. X plus 3/3, divide or slide?
Hold on.
Divide, because it divides evenly, right? What's 3 divided by 3? 1. How about x minus 1/3, divide or slide? Slide. Remember, if you can reduce before you slide, you have to do that. Can you reduce? No. So I'll slide the 3 on over, and that becomes 3x minus 1. So these are my factors, but they're not my solutions. How do I find my solutions? Make them equal to 0. Can we find the solutions in our head? If I set x plus 1 equal to 0, what's x going to equal? -1. If I set 3x minus 1 equal to 0, what's x equal? 1/3. Because add 1 to both sides, divide by 3, get 1/3, right? If you can't do that in your head or you're going to make a mistake, just write it out on your paper. But we've done it enough. I think you have this. So we found all of the key characteristics of our parabola. So now we're going to go back and we're going to graph all this stuff and we're going to label it and we're going to say what the domain is and the range is and our increasing interval and our decreasing interval and all that stuff. Okay? So I'm going to make a nice big graph. This is the only thing I'm graphing on this side of the paper. And I want plenty of room so I can label stuff. It's No need to jumble it all together like I had to do on my steps.
It's gonna open upward, right?
Yes, it opens upward.
So we can use this whole entire graph.
Yeah. So I know the graph opens up. That's not something like I can actually, I don't do anything at this point. But after I've finished graphing it, I need to make sure that my graph actually opens up because we know it's supposed to. My axis of symmetry is at x equals negative 1/3. Okay, so let me draw that in. And I usually like to plot my vertex first. It doesn't matter which one you do because they don't change. So on the x-axis, I'm going to have a vertical line that goes through negative 1/3 on the x-axis. Of course, I'm going to have to estimate where negative 1/3 is. And that was my axis of symmetry. Bless you. My vertex is at negative 1/3, comma negative 1 1/3. It should fall on the axis of symmetry. If it doesn't, something's not right. So at negative 1/3 on the x-axis, down to negative 1 1/3 on the y-axis. The y-intercept is at negative 1. So on the y-axis at negative 1, plot a point. And we know that parabolas are symmetrical. So that, without doing any math, I can just reflect that point onto the other side of the axis of symmetry. So if that point is 1/3 of a unit to the right of the axis of symmetry, I know there's also going to be a point 1/3 to the left of the axis of symmetry because it's symmetrical. Remember when we graphed absolute value functions and they were in the shape of a V? They were symmetrical also, and we could reflect points because we knew they were symmetrical. So I could do that without doing any math. So the x-intercepts, which we found by graphing, one of our x-intercepts was at negative 1. The other one was at positive 1/3. And I have all of the important parts. I know this is supposed to make a smooth U shape. So a lot of times students will graph their parabola and it will not look anything like a smooth U. It'll be all crazy. If yours is not a smooth U, something's not right with your math. Figure out what it is, otherwise it's wrong, because if it's not in a smooth U, you definitely know you did something wrong. We're laughing, I think. Okay, does our graph open upward like we said it should? It does. Okay, because it's opening down, and we said it should open up. We know something's not right. Oh, was crying?
I don't know. Sounded like someone was crying.
We thought they were laughing. Is this vertex at a maximum or a minimum? Minimum. Vertex is at a minimum. It's the lowest y value on the graph, right? We already knew that. We learned that previously this year. So let's answer some questions also that we've learned previously this year. What is the domain of this function? All real numbers. And if I wrote that in interval notation, it would be from negative infinity to positive infinity, right? On the x-axis, the left side's coming from negative infinity. And on the y-axis, it's going all the way to positive infinity. Kaylee, will you bring me that phone, please? And what's your range? Is your range greater than or equal to what? Negative 4/3 or negative 1 1/3. In interval notation, since I wrote the domain in interval notation, it would be from negative 1 1/3 all the way to where? Positive infinity. Okay, remember increasing and decreasing? You describe your increasing and decreasing intervals by what's happening on the x-axis. So on the left side of that graph, to the left of the axis of symmetry, is that increasing or decreasing? Don't look at the arrows. Arrows have nothing to do with it. What? Decreasing. Because as you're going left to right, your y values are getting smaller, right? In interval notation, where is that graph coming from on the x-axis? From negative infinity all the way to where does it stop decreasing? On the x-axis. Negative x-axis. 1/3. You describe your increasing and decreasing by the x-axis, right? So from negative infinity to when x is negative 1/3, it's decreasing. Increasing from left to right, where does it start increasing? Negative 1/3 all the way to positive infinity. And that's just review of things we've learned before. That's a lot of steps to graphing a parabola, is it not? Yes. So say you're taking ACT or SAT, and I don't know if you have to graph a parabola on there or not, but if you did, and you have a graphing calculator, won't it graph the whole thing for you? Yeah. But don't you have to know how to use the graphing calculator and have a graphing calculator to use? Otherwise, if you don't, then you have to know how to do it by hand. Okay? If you were asked to do that on a standardized test. Okay, backside. Example 2. We are going to graph f of x equals 2x squared minus 4x minus 1. So first of all, is this graph going to open up or down? It will open up. What's the next thing that we did on the first example? What did we find after we determined if it's going to open up or down? The axis of symmetry, right? And to find the axis of symmetry, we use x equals negative b over 2a. And we know that a is equal to 2, b is equal to negative 4, and c is equal to negative 1, which we don't need the c for axis of symmetry, but. So that is x equals, what's the opposite of b if b is negative 4? means you're going to have a double negative. So instead of negative b, we would write what? Positive 4 over 2 times a, which is 2 times 2. Which that is 4 divided by 4, which is 1. So axis of symmetry is that x equals 1. What else does that x equals 1 tell us? It's our axis of symmetry, but what is that x value also used for? It's the x value of the vertex, right? Alright, so which is the next thing we find is the vertex. To figure out the vertex, we already know the x value of the vertex is the same as the axis of symmetry. To find the y, take your equation, but instead of f of x, I'm going to use y. And I want to know a certain ordered pair. I want to know when x is 1, what is y? So wherever I see an x, I'll substitute in a 1 and solve for y. To be real careful on the order of operations, exponents come before multiplication. So what is 1 squared? 1. Now I've got multiplication and subtraction, so I do multiplication first. So we have y equals 2 times 1 is 2, negative 4 times 1 is negative 4, and bring down, don't forget the minus 1 on the end. Now I have just subtraction, so I'll work left to right. 2 minus 4 is negative 2, negative 2 minus 1 is negative 3. So my vertex is at when x is 1, y is negative 3. What is the next thing that we found in the first example? The y-intercept. And how did we find that? It's your c, right? What is c? Negative 1. That's the easiest thing to find. So if you know how a graph's supposed to open up or down and you know what c is, if it was a multiple choice, which on our test it won't be multiple choice, but those are two ways that you could figure out, you could eliminate a lot of the questions, right? Okay, what's the next thing we did? X-intercept. So that's when we solve for x, either by factoring, by completing the square, or quadratic formula. Alright, so I'm going to factor first. I know this is written above, a is 2, b is negative 4, c is negative 1, and I need two numbers that multiply together to give me AC, which a times c is negative 2, and two numbers that add together to give me b, and b is negative 4. What do you think? Let's see, I know negative 2 times positive 1 is negative 2, but negative 2 plus 1 is negative 1. What if I do positive 2 times negative 1? I get negative 2. But 2 plus negative 1 is positive 1. Well, does negative 2 have any other factors? No. So is this factorable? No. That doesn't mean that it doesn't have a real solution. It just means we can't find it by factoring. So we don't stop there. Yeah, if completing the square or quadratic formula, if it has an imaginary solution, then we know it won't cross the x-axis. But if it does not have an imaginary solution, then we need to find what those solutions are. So personally, I prefer quadratic formula over completing the square. So that's what I'm going to do. But if you like completing the square better and you can do it correctly, then you're free to do that in your notes. But I'm going to use the quadratic formula. Which we know is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. So that's x equals opposite of b. If b's negative 4, plug in that negative 4, it's going to turn positive 4, right? Because we'll have a double negative. Plus or minus the square root of b squared, that's negative 4 squared, minus 4 times 2 times negative 1, all over 2 times 2. Because 2 times a if a is 2. Yeah. We good with that? So obviously I have no idea where this location is on my x-axis. I need to simplify it as far as I can. So I get x equals 4 plus or minus the square root of, what's negative 4 quantity squared? 16. And then we have negative 4ac. I like to do it all together. Negative 4 times positive 2 is negative 8 times negative 8 times negative 1, positive 8, all over 4. So that's x equals 4 plus or minus the square root of 24 all over 4. Now if we were just solving the quadratic formula and I wanted you to leave your answer in radical form, I would want you to simplify 24 because it has a factor, a perfect square factor of 4. So I'd want you to simplify that. Okay? No, but it has a perfect square factor. Remember factor tree? 4 times 6, so square root of 4 is 2. But because I want to know, even if I do that, I'm going to get 4 plus or minus, I think 2 square root 6 all divided by 4. Am I going to know where that is on the x-axis? No. So I'm going to go ahead and turn that into a decimal because I want to know precisely or approximately where it is on the x-axis. So in this case, I would turn it into a decimal. If you were just simplifying the quadratic, I would want you to simplify as far as you can without turning it into a decimal. Okay? So if you put 24, square root of 24 in your calculator, you're going to get 4.9 something, something, something. So I'm just going to round that to 4.9. So x equals 4 plus or minus 4.9 quantity divided by 4. It's not just 4.9 divided by 4, it's the whole thing. So in order to simplify this and find my two solutions, I'm going to have to separate this into two problems. I'm going to have to do 4 plus 4.9 quantity divided by 4, and I'm going to have to do 4 minus 4.9 quantity divided by 4. So I can simplify that numerator. 4 plus 4.9 is 8.9, and 8.9 divided by 4 is approximately 2.2. Okay, my other solution, 4 minus 4.9 is negative 0.9. Divide that by 4. And remember, 4.9 is an approximation. We rounded it. So that's why I'm saying x is approximately negative 0.2. So those are my two x-intercepts. They're a whole lot easier to find on the graph than 4 plus the square root of 24 quantity divided by 4 and 4 minus the square root of 24 quantity divided by 4.
Can you draw that sign a little bigger?
Can I do what now?
The approximately sign.
Can I draw it bigger?
Yes.
You mean because you don't know what it looks like? Okay, so it's instead of two equal signs, it's like two squiggly equals, like make your equal sign a curve. Does that make sense? Two squiggles. Alright, so now I'm going to go draw all these important parts on the graph. Again, I'm only putting one graph. I know I feel like I'm wasting a lot of space, but such is life. We know this is going to open upwards, but we don't do anything with that, just knowledge. We know our axis of symmetry is at x equals 1. So there will be a vertical line that crosses the x-axis at positive 1. We know our vertex is at, when x is positive 1, y is negative 3. If our vertex is not on the x-axis, something's not right. And it's going to open up. So is our vertex at a maximum or minimum? Minimum. Our y-intercept is at negative 1. So on the y-axis, we have a point at negative 1. We can reflect that point across the axis of symmetry. So it is 1 unit to the left of the axis of symmetry. So we know there must also be a point 1 unit to the right of the axis of symmetry. I always feel like I'm drawing a Rudolph when I graph these. And I have the vertex and 2 points. Like, it's Rudolph. Should have made the nose red. And where it crosses the x-axis, that's what I found on this one by the quadratic formula. So I know it crosses the x-axis approximately at 2.2 and approximately at negative 0.2. Smooth U-shaped curve. You do not want it to be in a point. Graphs are in a point that make a V are graphs of absolute value equations, not graphs of quadratic equations. Is everybody cool with that? So the actual graphing part's quick. It's just figuring out all of the parts that we need to graph that takes time. So, what is my domain? All real numbers, or in interval notation, be from negative infinity to positive infinity. What is my range? What's the lowest y value? Remember, range is y value. So from negative 1 all the way, my y's, do they ever, when they're going up, do they ever end? No, so they'd be all the way to positive infinity, right? The left side of my graph, is it increasing or decreasing? Decreasing. So from left to right on the x-axis, where is it coming from on the x-axis? Negative infinity. And on the x-axis, where does it stop decreasing? At 1. I know it's, you want to say 3, but you're not looking at the y-axis, you're looking at the x-axis for increasing and decreasing. So it stops when at this point that has an x value of 1. So the right side is increasing from left to right. Where does it start increasing on the x-axis? 1. Where does it stop increasing on the x-axis? Positive infinity. Y'all good with that?
C.
Excellent. Anybody have questions? Comments? Concerns? Okay, I will stop the video.